Navigator to crew, time for parachute deployment is now. Okay, we have visual contact. We'll make a look-see pass shortly. Are you ready to go?
Roger, sir. All set back here.
Somewhere over the Pacific, 385 miles southwest of Hawaii, an Air Force crew is trying to catch a falling Cold War secret before the ocean does. The aircraft is a C-119 Flying Boxcar. The rear cargo door is open. Two 34-foot aluminum poles extend behind the fuselage, a trapeze loop of nylon strung between them. Below the tail, an orange and silver parachute is descending at 600 feet per minute, and beneath it hangs a gold-plated capsule the size of a kettle drum. The crew has missed twice already. In the cargo bay, the loadmaster is leaning into a harness, watching the chute through the open door, calling distances over the intercom. The first pass was high. The hooks swung over the canopy without touching it. The second pass was worse. The angle was off, and the pilot had to break away to avoid dragging the rig through the chute lines. Each missed pass cost altitude that the crew could not regain. The chute is now below 5,000 feet and falling. They will not get a fourth pass. If the chute touches the water, a self-destruct charge will fire, salt water will flood the capsule, and the film inside will sink to the bottom of the Pacific. The film is the entire mission. Corona was not a satellite as we understand them now. It had no permanent presence in orbit. It did not beam pictures back to Earth. It wasn't meant to last. It was designed to come apart. The vehicle that lifted off from Vandenberg Air Force Base was a stack of components, each with a job, each disposable. The Thor booster burned out and fell away. The Agena upper stage carried the payload into orbit, held it steady, aimed it, and was left behind. The camera exposed its film, wound it onto a take-up reel, and never flew again. The capsule separated from the rest of the vehicle, fired a retro rocket, dropped its thrust cone and heat shield, and shed mass at every step, until the only thing left was a small gold-plated bucket on a parachute over the Pacific. The cameras, though valuable, were not what America wanted to recover. It was the film. Everything else was packaging. In 1958, this idea sounded close to science fiction. No nation had ever recovered an object from orbit. No aircraft had ever caught one falling back from space. The transistor was 11 years old. The integrated circuit had been invented 7 months earlier. American engineers were being asked to do something nobody had done, on a schedule, in secret. They were asked to set up a chain of physical impossibilities, every link engineered to destroy itself in sequence, so that one small object could come home. This entire feat of engineering had to do with the pictures in those films, something America desperately wanted to see, and was unable to. In the late 1950s, the United States was making the most consequential decisions of the 20th century, based on guesswork. How many long-range bombers did the Soviet Union have? Nobody knew. How many intercontinental ballistic missiles? The numbers were rough. Where were the launch sites? No idea. The Air Force had estimates. The CIA had estimates. The estimates did not agree. Then came images from the May Parade in Moscow in 1955, which showed the Soviet Union had developed an alarming number of Soviet strategic bombers allegedly capable of reaching the U.S., nowhere near the number of bombers the U.S. had for the same purposes. Politicians called it the bomber gap. The U.S. was falling behind. In 1957, the Air Force estimated that the Soviet Union would have 500 intercontinental ballistic missiles operational by 1961. The CIA estimated 100. Neither agency could explain how it had arrived at its number. The Pentagon needed certainty. It needed to see through the Iron Curtain. There was one tool that worked. The U-2 reconnaissance aircraft, flying at 70,000 feet, had been photographing Soviet territory since 1956. The pictures were extraordinary. The problem was that the Soviets could see the U-2 on radar from the day it began flying. It was a solution that became more vulnerable by the day. On May 1st, 1960, a surface-to-air missile struck Francis Gary Powers' U-2 over Sverdlovsk. He ejected, came down inside Soviet territory, and was paraded on television. The cover story was finished, and so was the U-2 program over Soviet airspace. Eisenhower had been caught in a lie. America was blind, but not for long. Project Corona was by now in the final stages of testing, and in the next 110 days, they would achieve something unthinkable just a few years later. Eisenhower had approved Corona on February 7, 1958, because everyone in the room understood that the U-2 era could not last. When it ended, the United States would need something the Soviets could not shoot down.
T-minus 5 seconds. Mark.
Satellites were an obvious solution, but decades before the internet age, they needed a way to bring the picture home. They would have to do it the old-fashioned way. For the public, the program was called Discoverer, and every launch had its own press release. Some were even broadcast on TV. That was the genius of the deception. It was being displayed so blatantly, so openly, that they would not suspect foul play. As far as the Soviets knew, Discoverer was a scientific satellite project run by the Air Force, studying the biomedical effects of spaceflight and recovering capsules containing mice and monkeys for research for the development of space life support systems. Take some small critters to orbit in a specially adapted satellite and study the effects of space on them. Technicians and medical personnel who were completely unaware of the spy camera program were hired to train monkeys. Engineers even modified several early Corona recovery capsules to accommodate monkey passengers. Tragically, because these systems were secondary to the actual camera mission, several test monkeys died during ground tests. The cover story was so thorough that they actually launched several animals, though it was a total disaster. Discoverer 3 carried 4 black mice. The launches were public events. The failures were public, embarrassing the program and the country. Nobody outside a small compartment knew that every failed mouse-carrying capsule was a debugging run for a camera that did not officially exist. Mice overdosed on Krylon from the cages. The upper stage of the vehicle fired downward, driving the vehicle and 4 mice straight into the sea, and dozens of mice perished. It was theatrical, but that's what made it work so well. Corona had no interest in recovering the animals. Eisenhower had directed the Air Force to appear to shut down the return component of its reconnaissance program, then secretly transfer it to the CIA. The agency had faster contracting authority, tighter secrecy, and political insulation that the Air Force did not. The hardware was the same. The cover story was the lie. The chain inside the lie had roughly a dozen sequential physical events. The plan behind it had 4. 1. Launch a camera into orbit. 2. Expose film over denied territory. 3. Eject the film in a capsule. 4. Catch it in the sky before it reaches the ocean. Every one of those steps could end the mission. A booster that failed to light, a capsule that tumbled, a parachute the aircraft never found, and the film was gone, either burned on re-entry or sunk in the Pacific. The first link was a camera that had to photograph the Earth from space without destroying itself. The camera had to hold itself steady to within fractions of a degree, while everything around it refused to cooperate. The spacecraft was moving at 17,500 miles per hour, 100 miles above the ground, tumbling and drifting, taking a kick from every onboard system. From there, it had to sweep its lens across a strip of ground 130 nautical miles wide. It had to operate in a vacuum so complete that ordinary mechanical motion produced electrical effects nobody had to worry about on Earth. The first generation, KH-1, produced imagery at roughly 40-foot resolution. You could see a runway. You could see the aircraft on it. By the time the program reached its mature form, KH-4B, resolution had improved to between 5 and 7 feet. You could count the aircraft. You could even measure the wings. The film moved through the camera at high speed, dragged across rollers in a vacuum. In said vacuum, the friction between film and metal generated static electricity, and in the presence of moving photographic emulsion, That static electricity produced a phenomenon engineers called corona discharge. The film would arrive on Earth, scarred by lightning, the entire mission rendered unusable. The fix was a small unit called a pressure makeup sub, which held the inside of the camera barrel at 50 microns of pressure, just enough atmosphere to suppress the discharge without compromising the lens. The spacecraft's attitude was tracked by Horizon cameras, which fed pitch and roll data to an image motion compensation programmer. This connected the geometry of the panoramic scan in real time, telling the camera how fast to nod, how fast to cycle, and feeding cross-track yaw signals back to the Agena guidance system. By this point, it was less a camera than a self-correcting geometric instrument, and all of it was useless if the film could not get home. The thing that came home was small, the size of a kettle drum, and almost none of it was built to survive. The capsule was called the Satellite Recovery Vehicle. The crews called it the Bucket. Inside was the take-up reel, the film, and a battery. Everything wrapped around it, the heat shield, the thrust cone, the retro rocket, the parachute pack, the radio beacon, existed to be used up and thrown away on the trip down. Between those layers was a sequence of pyrotechnic events, each one fired in order by a small explosive charge called a squib. The timing was measured in milliseconds. The entire sequence had to execute in roughly 4 minutes, in a vehicle that the crew on the ground could no longer communicate with, on commands loaded before the satellite ever left Vandenberg. The spacecraft reoriented for separation. The capsule was kicked free in a reverse and downward attitude. Spin rockets fired to stabilize it. The retro rocket fired to slow it. D-spin rockets fired to stop the spin. The thrust cone separated. The capsule entered the atmosphere at roughly 18,000 miles per hour, and the ablative heat shield began to burn away, exactly as designed. The shield was not protecting the capsule by being tough. It was protecting the capsule by being consumed. Engineers later noted that the film itself was not a liability in this regard. Quote, "Film is an excellent ablative material. If the heat shield somehow failed, the outer layers of film would burn before the inner layers cooked." Below the upper atmosphere, the heat shield was released. The parachute cover blew off. A drogue chute was deployed to slow the capsule. The reefed main chute opened in stages, first partially, then fully, to keep the shock load from tearing the canopy apart. Every one of these events was one squib, one timed pulse. The lesson came from Discoverer 13. Discoverer 13 returned the first object ever recovered from orbit in August 1960, but it carried no photographic payload, and during the recovery sequence, one of the 4 squibs on the 4-body separation pistons failed. The capsule survived because the other 3 squibs were enough. Engineers studied the failure and redesigned the legs so that if any 3 of the 4 fired, the parachute cover could still release. The capsule was designed assuming destruction. The mission was designed to intentionally lose mass. But even if the capsule survived the fire, it would not survive the ocean. Everything the program had built came down to this. An airplane had to snatch a falling capsule out of open sky with a hook in the few minutes before the Pacific swallowed it. 13 Discoverers had flown before this one. Every one of those had failed, and each one had failed differently. Discoverer 1 was lost after reaching orbit. Discoverer 2 missed its re-entry and came down near Spitsbergen, possibly close enough for the Soviets to recover. Discoverer 10 exploded on the pad. Discoverer 3 carried 4 mice that died before launch. Discoverers 5 and 6 fired the retro rockets the wrong way. Discoverer 7 tumbled out of control. Discoverer 8 re-entered but lost its chute. Discoverer 11 ejected its capsule and watched it vanish. Discoverer 13 came home, the first object ever recovered from orbit, and it carried no film at all. Discoverer 14 would be different. The unit that did the catching was the 6593rd Test Squadron, flying out of Hickam Field in Hawaii. Their recovery area was was 36,000 square miles of open Pacific, divided into a primary ballpark 60 miles wide by 200 miles long, and a southern outfield 60 miles wide by 400 miles long. The aircraft worked in a layered pattern, call sign Pelican 1 through Pelican 9, Pelican 1 sitting in the most likely recovery zone, and Pelican 9 patrolling the least likely outfield. The aircraft was called the C-119 Flying Boxcar. It had no onboard radar. It homed in on the capsule's radio beacon. Support came from RC-121 constellations flying higher, using radar to vector the C-119s toward the descending chute. The recovery rig was two 34-foot poles extending from the open cargo door, a trapeze loop of nylon rope strung between them, fitted with bronze grappling hooks attached to a winch on a 500-foot cable. The crew would make a visual look-see at 15,000 feet, flying past the chute to confirm its condition. A teardrop pattern outbound followed, 20 to 30 seconds before the turn back in. Then came the committed descent, 15 to 1,600 feet per minute at 120 to 130 knots, overtaking the chute while matching its rate of fall. The hooks had to take the canopy cleanly. Too low, and the canopy could invert. The rope shock load, the winch overspeed, and the aircraft could be dragged into its own descent.
Okay, we have visual contact. We'll make look-see past shortly. Are you ready to go?
Roger, sir. All set back here.
On August 18, 1960, the crew of Pelican 9 found Discoverer 14 on their beacon receiver. They rolled out on the bearing, made the visual at 15,000 feet, missed on the first pass, missed on the second, and lined up for the third. At 8,500 feet, the hooks engaged. The crew saw the ripple of the collapsing chute. They felt the line shock load through the winch. The loadmaster called out the words the program had waited 2 years to hear, quote,
What? Which operator? Man, that was a real beauty. Right pole contact.
Discoverer 14 was the first successful catch. Now someone had to see what was actually in the film. The first analysts to see corona imagery were a small group at the new National Photographic Interpretation Center. The negatives arrived from Eastman Kodak's covert processing facility, codenamed Bridgehead, where the recovered film was developed under Talent keyhole security. The interpreters laid the film on light tables and began counting. What they counted was less than they expected. The Soviet bomber fleet and the Soviet missile force were both smaller than CIA estimates. The fields the Air Force had insisted were missile complexes were sometimes empty. The bomber gap, which had driven a generation of American defense spending, did not exist. The missile gap, which John F. Kennedy had run on in 1960, did not exist either. The estimate that the Air Force had made of the USSR having hundreds of intercontinental ballistic missiles was especially humiliating in hindsight. The actual figure, when Corona finally made it possible to count, would be 4. Not 400. 4. America had been arming itself against an enemy it had imagined to be larger than it was. Over 12 years, Corona flew 145 missions. It returned more than 800,000 images. It mapped the Soviet Union, China, North Korea, the Middle East, and Southeast Asia. It fed the Cuban Missile Crisis, the Sino-Soviet split, and Vietnam targeting. By the early 1970s, Corona imagery had become the foundation of arms control verification, allowing the United States to sign the Strategic Arms Limitation Treaty in 1972, with confidence that the Soviets could not cheat without being detected. The final Corona launch was on May 25, 1972. The final recovery, May 31st. The program was retired and replaced by satellites that transmitted imagery electronically, with no film, no capsule, no chute, no hook. In 1995, President Clinton ordered the Corona archive declassified. The film that had been caught in the sky now sits in the National Archives. The most important Cold War weapon America ever built shot pictures. The men who made Corona work were never allowed to know what it was for. They caught the most important pictures of the Cold War and were told only that they had caught something important. the crew of Pelican 9 reeled in Discoverer 14 at 8,500 feet over the Pacific. Corona operated under talent keyhole compartmentalization, the security system so tight that the people who did the work were not allowed to know its consequences. The pilots flew the catches. The loadmasters reeled the buckets. The winch operators logged the times. None of them saw the negatives. None of them sat in the rooms where the bomber gap was closed. A small number of people at NPIC saw what the catches meant. They could not tell the pilots. The pilots could not tell their wives. The capsule arrived, was carried off the aircraft, and disappeared into a processing chain that the recovery crews were never cleared to see. For 35 years, the men of the 6593rd Test Squadron knew only what they had done. They did not know what it had been for. In 1995, when the declassification order came, most of them were old. Some had passed away. The film they had risked C-119s and JC-130s to recover, the film they had caught over the Pacific, was now on the open record. Some of the men learned, for the first time, what they had actually been catching.